So for the first method, I've created a ALU that holds four different operations. So here I create a input that is 4 bits. I create a B input that is 4 bits. I have a select for my selector, which is 2 bits, and my X output will be 4 bits. So here in my architecture, describing the behavior of this system, when I select the 0, 0, I will add A and B. When I select 0, 1, I will AND A and B. When I select 1, 0, I will OR A and B. And when I select 1, 1, I will XOR A and B. So here I've created a test bench for me to see if my simulation will hold true due to my ALU entity and architecture behavior. So here I've created a component for my ALU, and I have signals that set equal to 0. And here is where I have my select, and it will wait 100 nanoseconds, and then I have my select 0, 0, 0, 1, 1, 0, and 1, 1. So here, when I've ran my simulation, like stated before, you have to wait for 100 nanoseconds. So first 100 nanoseconds will be 0, 0, 0, 0. Then say I want to select 0, 0, which will give me an add. You will add A and B. So 0, 0, 0, 1 is 1, and 0, 0, 1, 0 would be 2. So my A plus my B would be equal to X, which is 0, 0, 1, 1, which is the binary of 3. Here, if I select the 0, 1, I'm ANDing my input A and B, which means it only holds true if there's a 1 and a 1 in both inputs. So here I have 0, 1, 0, 1, and I have 1, 0, 0, 1. Here it's a 1, so you'll have a 1 at this bit in your 4-bit binary. So when you AND 0, 1, 0, 1 and 1, 0, 0, 1, you get 0, 0, 0, 1. Here, my select will be 1, 0, which is ORing A and B. So if I OR, it will only be true if there's a 0 and a 1. Or it would only hold true if it was a 0 and a 1 or a 1 and a 1. It won't hold true if it's a 0 and a 0. So here, in this bit, it won't hold true. So when I OR 1, 0, 0, 0, and my input be 1, 1, 1, 0, I'll get an output X of 1, 1, 1, 0. Here, my select is 1, 1, so I will XOR A and B. So XOR holds true if there's only a 0 and a 1. In this case, there's a 0 and a 1 in all of these cases. 1, 0, 1, 0, 0, 1, 0, 1. So when I XOR 0, 0, 1, 1 and my input be 1, 1, 0, 0, I will get 1, 1, 1, 1. Here I go back to 0, 0, which is addition. So 0, 0, 1, 1, which is 3, plus 0, 1, 1, 1, which is 7. 7 plus 3 will equal 10, and in binary it's 1, 0, 1, 0. Here, I select the 0, 1, which is ANDing, and again, it only holds true if there's a 1 and a 1. So in this case, there are no 1 and there's not a 1 and a 1 in the same place. So when I AND 0, 1, 0, 1 and 0, 0, 1, 0, I will get 0, 0, 0, 0 because there's no 1s. And that's how you simulate my method 1.